Okay, let's solve some problems using this test. Here, first of all, we will find and classify the critical points of the given functions. In the first problem, we are given such a function. To apply second derivative test, first of all, we need to calculate the critical points, and then we will calculate a, b, c, and delta. Then we will apply directly the results of the second derivative test. So step 1. Critical points. To find critical points, first of all, we need to calculate the first partial derivatives. So here f sub x equals, this means the derivative of f with respect to x means that here y should be regarded as constant. So if I evaluate the derivative with respect to s, the first derivative of the first term will be 4x cubed. There is no x here, and this is constant. I have 0. And here, a derivative of x is 1. The derivative of 4xy will be minus 4y with respect to x. And plus 0 we have, so I have 4x cubed minus 4y. Okay, so derivative of this function with respect to y will be 4 this time 0 from the first term and 4y cubed from the second term. Here x is constant and the derivative of y is 1, so I have minus 4x and plus 0, which means we have 4y cubed minus 4x. Okay, so as you can see, they are polynomials, so it means they are defined everywhere. There is no point at which these first partial derivatives do not exist. Okay, so it is enough to use it is enough to equate these derivatives to 0 to find the critical points. Okay, I will calculate critical points using these equalities. If I can find a point which makes this partial derivative and this partial derivative 0 at the same time, then I can call it it is a critical point. So let's try to continue with this. F sub x is the common parentheses of 4. I have x cubed minus y equals 0, which means here I have x cubed minus y is 0. Okay. And in the second partial derivative, we have in the common parentheses of 4, y cubed minus x is 0. So I have y cubed minus x is 0. We should solve these equations at the same time. So to do this, I will substitute y equals x cubed to the first equation from the, here, using the first equation, y equals x cubed, we have, I will substitute this y equals x cubed into the second equation. Okay, y here I have y equals x cubed, and I will directly substitute it here. So we have this y 0, here y equals x cubed. So I have x cubed minus x is 0. So x to the 9 minus x is 0. In the common parentheses of x, I have x to the 8 minus 1 is 0. Okay, so it says that x is 0 or x to the 8 is 1, which means x is 0 or x to the 8 x is minus 1 or x is 1. Okay, so we have possibilities for x's. It's time to find the calculate y. So to do this, I will use that equality, because at the beginning I assume that y is x cubed using this equation. So at the end, when x is 0, y is x cubed. Since this is, we have 0 cubed, we have y is 0. When x is 1, y is 4 this time plus 1 cubed, which is 1. And when x is minus 1, y is minus 1 cubed, which is minus 1. So we have 3 critical points. When x is 0, y is 0. When x is 1, y is 1. When x is minus 1, y is minus 1 are critical points of f. Okay, so this is the first step. let's move on the second step here, which is the calculation of A, B, and A, B, C, and delta. Okay, step 2. Calculate A, B, C, and delta. To do this, we need to calculate second partial derivatives, okay? And so we know that f sub x, first partial derivative is 4x cubed minus 4y, and f sub y is 4y cubed minus 4x. We have found it in the first step, so I can calculate the second partial derivatives. Derivative of f with respect to x 2 times will be the derivative of f sub x with respect to x, which means 12x squared, and f sub y, derivative of this function with respect to y, I have 12y squared, and derivative of f with respect to x and y, derivative of f sub x with respect to y, so derivative of this function will be minus 4. Okay, so these are the second partial derivatives, and we know that a is the let me calculate these during the other steps. Okay, so let's calculate delta xy. It equals f sub xx times f sub yy minus f sub xy squared, which means I have 12x squared times 12y squared minus 4 squared. So I have this 144x squared y squared minus 16. So this is our delta xy. Okay. It's time to use the test to decide the type of the critical points classification. Okay. First of all, to classify the critical points, I will start with the first critical point, which is 0, 0. Okay, and the test says this. First of all, we have 0, 0 points. I will substitute 0, 0 here, delta. Delta 0, 0 is, if you substitute 0, 0 here, you will have minus 16, right? And which is less than 0. If delta is less than 0, you can directly say that 0, 0 is a saddle point, which means f has no local mean or local maximum at 0, 0. Okay, the type of this critical point is saddle point. And then it's time to classify 1, 1. Again, to do this, I need to substitute 1, 1 delta here to calculate the, to decide the sign of delta. So I have 144 minus 16, which is greater than 0. So if it is greater than 0, you should look at the sign of A for this time. Okay, if delta is greater than 0, depending on the sign of A, you can decide that AB is local mean or local max here. Okay, so A is that AXY is f sub xx, which means I have 12x squared. If you substitute 1, 1 here, you will have 12, a positive value, which is greater than 0. So I can say that by second derivative test, f has a local minimum at 1, 1, and f of 1, 1, which is equal to minus 1, is a local minimum value of the function. Okay. Then it's time to analyze minus 1 and minus 1. So again, I will use the same steps. Delta minus 1, minus 1. If you substitute minus 1 here, minus 1 squared will be 1, minus 1 squared will be 1. So I have again 144 minus 16, which is positive. And again, I will use a minus 1 minus 1. Why? Because the sign decide the maximum or minimum of the decide the function has a local mean or local max at that point. So a minus 1 will be 12 minus 1 squared, which is 12. So it is less than greater than 0. Sorry. So at the end I can decide this again. F has a local minimum at minus 1 and f of minus 1 which equals minus 1. You can obtain this using the given function. If you substitute minus 1 here, 1 plus 1 minus 1 will be again 1. So I have 1 plus 1 minus 4 plus 1, which is minus 1. Okay, minus 1 is a local minimum value of the function. Okay, so we have 3 different critical points. One of them is saddle point, 0 is saddle point, and 1 is local mean, and minus 1 is again local mean. And the local minimum value of the function can be calculated by substituting the point at the given function, and the result is same for this time, minus 1 and 1. You may have different values here, okay, it doesn't matter, but in this, for this function we obtain the same values, same local minimum values here. Okay. Let's continue with the second problem, and for this time we will want to find and classify the critical points of this function. Again, this first step will be finding the critical points. So to find critical points, I will calculate the first partial derivatives here, f sub x. And here I have 3x squared over 3 minus 1. And those are constants with respect to x, so derivatives of those terms will be 0. So we have x squared minus 1. F sub y will be, the derivative of this term and this term is 0 because they are constant with respect to y. And I have minus 3y squared over 3 plus 1, which means I have minus y squared plus 1. Again, we have polynomials and they are defined everywhere, so there is no point which makes these first partial derivatives do not exist. Okay, so here to obtain critical points I will equate first partial derivatives to 0. As you can see, there is no need to solve these equations together because we have x, only x in the first equation and only y in the second equation. I can directly solve them. X squared is 1, so x is minus 1 or x is 1. And here y squared is again 1, so which means y is minus 1 or y is 1. So it means when x is minus 1, y can be minus 1 or 1. So I have minus 1 and minus 1 from the first part. We have 2 different critical points. And when x is 1, again y can be minus 1 or 1. So I have 1, minus 1 and 1 are critical points of the given function. So now it's time to calculate A, B, C, and delta here. Step 2. Calculation of second derivatives. Okay. A, B, C, and delta. So A, x, y is second partial derivative of this function with respect to x. To do this, it's enough to evaluate derivative of this function, which is 2x. Okay. B is bxy is second partial derivative with respect to y, so it is enough to calculate the second derivative with respect to y of this function, which is minus 2y. Okay, and cxy is f of xy, so the derivative of f sub x with respect to y is 0. So which means I have delta equals axy times bxy minus c squared xy. So as a result, delta xy equals 2x times minus 2y minus 0 squared. So I have minus 4xy. Okay, we will use these to classify the critical points of this function. Okay, I need delta and a actually, right? I will write it here. Step 3, classification. And we know delta xy is minus 4xy, and we know axy is 2x. Okay, let's start with the first point, minus 1 and minus 1. So if you substitute minus 1 and minus 1 in delta, you will obtain minus 4, which is less than 0. So I have a saddle point here. Okay, minus 1 is a saddle point. So there is no local max or local minimum at that point. F has no local minimum or local maximum at minus 1. Okay, so let's try to find the type of the second point, which is minus 1. If I substitute it to delta minus 1, then I will obtain minus 4 times minus 1, which is 4. 4 times 1 is 4, so a positive value. So if you have positive value, you should look at the sign of a here. A minus 1 is minus 2, which is less than 0, right? So it says that f has a local maximum at minus 1, and the value of this local maximum is f of minus 1, which is, you can obtain the result just substituting minus 1 and 1 here. Then the result will be 4/3 is the local maximum value. Okay, so let's try to analyze this third point, which is 1 minus 1. Again, first of all, I will substitute it in the delta. Minus 4 times 1 will be minus 4. Minus 4 times minus 1 will be 4. Again, it is positive, and I will calculate a at the point, and a is 2x, so I have 2 for this time, which is positive. So it says that f has a local minimum at 1 minus 1, and the local minimum value is minus 4/3. This can be obtained by substituting the point in the function is a local minimum value. And we have one more point, which is 1. If you substitute 1 in the delta, you will obtain minus 4, which is less than 0. So if it is less than 0, 1 is a saddle point. So it means there is no local max or local min here. 1. Okay, we have 4 different critical points. First one is saddle, and the fourth one is saddle, but here in the second point, which is minus 1, this is a local maximum point. F has a local maximum here, and at 1, F has a local minimum. We have 2 saddle points and 2 local extrema. Okay, let's try to find and classify the critical points of a given function x minus 1 times natural logarithm of x times y. Okay, here again we will start with step 1, critical points, finding critical points. And to do this, we need to first of all calculate the first partial derivatives. F sub x, here we have multiplication, right? Because of that, we will use product rule here. Derivative of first part is 1 times natural logarithm of xy plus first function times derivative of second function. Because of the natural logarithm, I have 1 over x times y first of all times, because of the chain rule, we need to calculate the derivative of the inner function here, and the derivative of x times y with respect to x is y. Okay, so you can cancel common terms, and you will have a natural logarithm of xy plus x minus 1 over x here. Okay, and in the second partial derivative, we have just directly we will apply the derivative with respect to the rules for derivative with respect to y, because there is no y here, this is constant. I will write it directly here, and there is y in the natural logarithm. Because of that, we will evaluate the derivative of that part. And because of the natural logarithm, first of all, I have 1 over xy, and the derivative of inner term with respect to y is x, because x is constant, y is a independent variable here. I can cancel x's, so I have x minus y, 1 over y. So to evaluate the derivatives, we will first of all equate them to 0, okay? So critical points, not derivatives, sorry. F sub x equals natural logarithm of xy plus x minus 1 over x equals 0, and f sub y equals x minus 1 over y equals 0. Normally, this function and this function does not define when x is 0 and when y is 0, but these points are not in the domain of the function. You should be careful about that. They are not critical points, because when x is 0, I have natural logarithm of 0 here, which means this function is not defined here, because we know that the natural logarithm function, domain of the natural logarithm function is the positive real numbers. And similarly, when y is 0, we have again natural logarithm of 0. So 0, if x is 0 and y is 0, you may think that we may have a critical point here, but they are not in the domain of the function. So because of that, they are not critical points. Okay, critical point is a point in the domain. You should be careful about that. So we have only critical points come from these equations to equating the first derivatives to 0. Okay, so equating the first part is a little bit difficult. Because of that, I start with the second part. So x minus 1 over y is 0, which means x minus 1 is 0, so x is 1. Okay. Using this result comes from the second part, second equation. I will find y by substituting x in the first equation. So we have this natural logarithm of xy plus x minus 1 over x is 0, right? And x is 1. So natural logarithm of y plus 0 is 0, which means natural logarithm of y is 0, so I have y is 1 here. So we have only one critical point, which is 1, 1. Because when x is 1, we have only y is 1 result. So as a result, 1, 1 is the only critical point here. Okay. If it is the only critical point, it's time to calculate A, B, C, and delta. Okay, A, B, C, and delta. Calculation of those values. So A is second derivative of this function evaluated at, second derivative of this function with respect to x, and we will evaluate it at 1, 1 later. So this is our first function, first derivative with respect to x. I will evaluate the derivative of this function with respect to x to obtain a. And from here I have 1 over xy times derivative of inner term with respect to x is y plus, and derivative of second term will be, I can rewrite it like that. It will be easy for us. Here, if you rewrite this term like that, natural logarithm of xy plus 1 minus 1 over x. This can be rewritten like that. Derivative of 1 is 0, and the derivative of minus 1 over x will be plus 1 over x squared. Okay, so I have 1 over x plus 1 over x squared here. And b is derivative of f with respect to y 2 times. So I will evaluate the derivative of this function with respect to y, which means I have x minus 1, this is constant, times 1 over y. And the derivative of 1 over y is minus 1 over y squared. So I have x minus 1 over y squared. Okay. And c will be f of xy, and derivative of this function with respect to y, this part will be 0 because there is no y here, and derivative of this function will be 1 over xy times derivative of the inner term with respect to y is x, so I have 1 over y. At the end, delta will be a times b, which means 1 over x plus 1 over x squared times b. I will take this minus here, x minus 1 over y squared minus square of c, 1 over y squared. Okay, so it's time to classify 1. Okay. We know what is a, we know what is delta. First of all, to classify step 3, classification. To classify a 1 critical point, I will substitute first of all 1 in delta. If you substitute here, you will have 1 minus 1 over 1 will be 1 plus 1 over 1 cube square, sorry, is 1 again times 1 minus 1 is 0 over y squared, which is 1 squared, minus 1 over 1 squared. So from here I have 0 minus 1, which is minus 1. So it is less than 0, as you can see. So if it is less than 0, it means 1 is a saddle point. It says that f has no local minimum or local maximum at 1. Okay. Let's look at that problem. For this time, we have a function which is given as e to the x times cosine y. Again, I will start with step 1. Step 1. Critical points. Let's start with the first partial derivative with respect to x. And here we have a constant function with respect to x, right? Cosine y. And the derivative of e to the x is itself. And the first partial derivative of this function with respect to y, for this time, e to the x will be constant. And the derivative of cosine y is minus sine y. So I have minus e to the x sine y here. So to obtain critical points, because again we have a function, two functions here defined at any point in the plane, it is enough to equate them to 0 to find the critical points. So I have f sub x e to the x cosine y is 0, f sub y equals minus e to the x sine y is 0. Okay, so let's look at the first equation. E to the x cosine y is 0. all we know that e to the x is always positive, right? So this may happen if and only if cosine y is 0 here. So it says that y is 2n plus 1 over 2 pi. So here n is any integer. For example, pi over 2, 3 pi over 2, minus pi over 2. Okay, at those points, cosine has the value 0. Let's check the second function. Minus e to the x sine y 0. And again, e to the x is a positive number, so it can't be 0 at any point. It means we have this equation to obtain the first derivative with respect to y is 0, okay? So it means if sine y is 0, y is n pi for this time. Pi, 2 pi, 3 pi, minus 4 pi. Okay, at these points, a sine function has the value 0. So, from the first part, I have y like that. From the second part, I have y and pi. And as you can see, they are not equal, right? 2n plus 1 over 2 pi, not equal to n pi. If you try to solve it, you will obtain directly multiply it with 2 n pi. 2n pi will be cancelled. Pi equals 0. So there is no such an equation, right? There is no such an equality. So because of that, this equation does not hold, which means there is no critical point to classify. If you don't have a critical point, you can't classify the critical points of the given function. Okay. On the other hand, you can look at that part also. Cosine and sine cannot be equal to 0 at the same time. Okay, so you don't have a solution for this system. Okay, for these two equations, because cosine y and sine y cannot be equal to 0 at the same time. Okay, let's solve the other problem. We are given again a function as y times sine x, and we want to classify the critical points, if exist, of this function. And step 1, critical points. Again, first of all, let's calculate the first partial derivatives. Y is constant, derivative of sine is cosine y, cosine x here we have. And f sub y will be, derivative of y is 1 and sine is constant, so I have sine x. To obtain the critical points, we will equate those partial derivatives to 0. From the first part, I have y is 0 or cosine x is 0, which means y is 0 or x is 2n1 over 2 pi. Okay. And here, sine x is 0, means x is 2n pi. And again, n is integer. So what is the meaning of this result? When y is 0, x can be these numbers. When x is 0, x can be these numbers, but this can't be happen, right? Okay, we have two possibilities here. Y is 0 and x is 2n pi. And on the other hand, x is 2n pi, 2n plus 1 over 2 pi, and x is 2n pi. And this can't be happen because 2n plus 1 over 2 pi is not equal to 2n pi. Okay, but here we have some critical points, because 2n pi, when x is 2n pi, y can be 0. Actually, we have infinitely many critical points here. So 2n pi 0, here n is integer, are critical points of given function. We have infinitely many critical points, infinitely many. Okay. Okay, so if you have critical points, you should calculate A, B, C, and delta. Okay, so A is f sub xx. I will evaluate the derivative of this function with respect to x, which means minus y sine x we have. B is f sub yy. Derivative of this function with respect to y is 0. C is fxy. So the derivative of this function with respect to y is cosine x. So using this, delta xy will be 8 times b minus c squared, which means minus y sine x times 0 minus cosine squared x. So I have this delta xy equals minus cosine square x. Okay, so if this is the case, it's time to classify those critical points. Step 3, classification. Okay, we have infinitely many critical points, but we have only one form, so it's enough to substitute that form in delta first of all. So I have delta 2n pi 0. Because it is minus cosine x squared, I will write cosine minus cosine squared of x, which is 2n pi here. I'm sorry, not 2n pi. This is n pi. So sorry for this. And those should be n pi also. There is no such a need to make it even. So I have n pi here. So this is also n pi, which means we have minus 1 squared, because all we know that cosine n pi equals minus 1 to the n, right? So first of all we have n, then we have squared. So I have minus 1 to the 2n, which is minus 1 directly. Okay, so delta n pi 0 is minus 1, which is less than 0. If it is less than 0, those n pi 0 critical points are saddle points. So there is no local max or local minimum at these points. There is no local min or local max at these points. Okay, so I want to summarize it one more time. By solving these equations, we have obtained that we have only n pi 0 critical points. Okay, but because n can be any integer, we have infinitely many critical points. So to analyze, to classify those critical points, we calculate a, b, c, and delta. We have obtained that delta is minus cosine squared x. Okay, delta is minus cosine squared x here. Then if you substitute n pi 0 points, because the critical points are n pi 0 are critical points. If you substitute n pi here, then you will have minus cosine squared n pi. And we know that cosine n pi is minus 1 to the n. So minus 1 to the n squared, which means I have minus 1 to the 2n. So this is even. Minus 1 to the even number is 1. So I have at the end minus 1. Because delta is minus 1 and it is less than 0, we have saddle points at these critical points. They are saddle points, so there is no local minimum or local maximum here. Okay, this is the end of this video. See you on next video.